Hi, good morning to everyone. We have discussed the recursion in C programming. We have seen the examples, finding the sum of n numbers which are stored sequentially, right? Say 1, 2, 3, 4, etc. n, without an array. Say 1 plus 2 plus 3 plus etc. n. We have seen how to print the numbers using recursion. Then we have seen how to find the factorial of the given integer. Then how to print the Fibonacci sequence using recursion. We have discussed the applications of recursion with respect to these problems. Hope all of you have gone through the previous sessions. Have any doubts in that session? Have any doubts so far? Shall we move on to the next problem?
Yes, sir.
Okay, please take the next problem. This is the decimal to binary conversion. Decimal to binary conversion. Please recall that we have already discussed this conversion in unit number 1. We have designed the example, right? How to make the conversion. For example, decimal 85, 85 in decimal. This is equal to what in binary, right? We need to find the index, the number system to 85, right? This will be successively divided by 2. 85 is divided by 2. 4 into 2, then 2 into 2, 4. Remainder is 1. This is the remainder 1. Then again dividing 42 by 2, the quotient is 21. Remainder is 0. Then dividing this by 2, quotient is 10. Remainder is 1. Then dividing this by 2, 10 by 2, 5 into 2, 10. Remainder is 0. Then 2 into 2, 4. Remainder is 1. 2, 1 into 2. Remainder is 0. So these are the reminders obtained. Reminders obtained. These reminders should be returned in this order. Say 1, 0, 1, 0, 1, 0, 1. 1 0 1 0 1 0 1 1 0 1 0 1 0 1. This is the equivalent binary representation. To verify that, you can check it in the reverse order. Here the place value is 1 into 2 power 0, that is 1. Here this is 2 power 1, right? This is 2, this is 4. Here this is 8. Here the place value is 16. Here the place value is 32. Here the place value is 64. So multiplying the individual bits with the corresponding position values and adding these, we will get 1 into 64, 64. Then 0 into 32 plus 0 into 32 plus 1 into 16, 16. Then plus 0 into 8, 0 plus 1 into 4, 4. Then plus 0 into 2, 0 plus 1 into 1, 1. 64, right? 16, 70, 80. This is 4, 84. plus 1, 85. So 85 in decimal, this is equivalent to 101010 in binary representation. Now we are going to devise the algorithm to convert this decimal to binary representation, and let us check its implementation in C language. Have any doubts in this conversion decimal to binary? Okay,
No, sir.
good. See how to devise the logic. So taking the same number 85, it seems we are divided by 2, 42, and we have recorded the remainder. Then subsequently divided by 2, 21, we have recorded the remainder. So quotient is subdivided by 2 until the quotient becomes here 1. 1 into 2, 2. But then the remainder is 0. Or in case here this is 3. 3, right? 1 into 2, 2. Then the remainder is 1. So how long we need to process until, what is this? This is the last quotient. Until the quotient becomes 1, please continue this division process and perform this one, right? That means perform the remainder operation. Continue this process. So just think of how can we continue or how can we convert this into the equivalent algorithmic representation, that is pseudocode or normal stepwise procedure. We need to start with, right, step 1, start. Step 2, we need to input one integer. I write in short, write input n. N is the integer. We need to convert the integer n into the equivalent binary representation. Step 3, how do we write in terms of, right, normal English like statement? We can say divide the given integer divide n by 2 and record or keep the remainder. Record or keep the remainder. Then step 4, we need to update a value of n. Initially n is 85. N is 85. Here this 42 is nothing but the integer division. That means n is equal to n by 2. N is subdivided by 2. Then the remainder is recorded, or we need to keep the remainder. This is the remainder. Since this is the iterative process, how long we need to continue the process until the value of n becomes 1. So here, this is actually the quotient. We can say n is equal to n by 2. So perform the operation n is equal to n by 2. Then step 5. In step 5, what we can say, we need to transfer the control to step 3. So step 3, 3 and 4 are going to be continued, right, until the value of n becomes 1. So we can write in terms of English-like statements, repeat steps 3 and 4 until n becomes 1. For example, here, this is the updated value of n. N reaches 1. Then we need to print the reminders in the order, right? So the order is important. This is the first reminder, second reminder, third reminder, and this is the last reminder. 0. Sorry, this one. Last reminder. In that case, we need to take this one also. What is this one? This is the last stage value of n. So we need to process the reminders, right, and print the reminders in the reverse order. So step 6. Finally, when n becomes 1, whatever is the case, suppose n is equal to 2. 2 is represented as 1, 0. N is 3. 3 is represented as 1, 1. Suppose n is 11. 11 is represented as 8, 4, 2, 1. 8 plus 2 plus 1. So 1, 0, 1, 1. So finally, when n reaches 1, we need to terminate the process. So how do we write the well-defined instruction print n and the reminders in the reverse order? First reminder, last. So this is the first reminder, next one, second reminder, third reminder, and this is the last reminder. So we are printing the reminders in the reverse order. So right here, print n and reminders in the reverse order. Print n and the reminders in reverse order. Then step 7, stop. Step 8, end. Terminate the process. This is the algorithm to convert the given decimal into the equivalent binary representation. Or the step 5, right, can also be brought here in step 3, right? You can write repeat steps 4 and 5 until n becomes 1. So this can be moved to step 4, n is equal to n by 2. This can be moved to step 5, so whatever it is. This is the algorithm or the steps for the conversion, required conversion. The thing is, how do we implement this algorithm in C language? What are the things required? We can use a function concept, no problem. Function may pass or function may get one integer from the calling phase. That integer, say a decimal, needs to be converted into the equivalent representation. So conveniently we can use a function because every stage we need to divide the integer by 2 and recording the reminder. So we need to keep the reminder, right? And finally we need to print the reminders in the reverse order along with the final value of n. That case, we need to think of what are the features required. Since once you perform 85 by 2, the reminder, right, this will be stored in some variable. For the value of 85, we need say 1, 2, 3, 4, 5, 6, 7. Am I right? 1, 2, 3, 4, 5, 6, 7. 7, right, variables are required to store these values, zeros and ones. In case if the input is 11, 11 is represented as 8, 4, 2, 1, right? So 8 plus 2 plus 1. 1, 0, 1, 1. 4 variables are required. In case 3 or 2 variables are required to store these reminders, right, along with the value of last one. Hence, it is better for us to use the array representation. We have right even discussed the basics in arrays. For example, if we define, please recall that int x of 5, suppose we have x1, x2, x3, x4, x5. When we need these 5 variables, instead of declaring these as x1, x2, x3, x4, x5, we can declare it in a C language as int x of 5, so that what is x? X is the name of the array and the corresponding indices, subscripts are normally starts at 0, 0, 1, 2, 3, 4. So this is the location. This is accessed by x of 0. This is accessed by x of 1. This is accessed by x of 2. This is the actual value of x of 3. And this is the actual value of x of 2. So as of now, just to think of how the array elements are represented and size of the array, so that these reminders can be stored in the array representation. This may be stored at 0th location, x of 0. This is stored at the location in the array x of 1. This is stored at the second location x of 2. This is stored at x of 3. This is stored at x of 4. This is stored at x of 5 location. So one more stage, right? If you divide this by 2, right? The 1, 0, right? Again, right? If you divide final stage, for example, where is this one? Yeah, 1. If you divide, right, this 1 by 2, what happens? Quotient is 0, remainder is 1. So you can also think of, right, this logic. So that this 0 is omitted, you can write the reminders, right, x of 5, this is stored, for example, x of 6. This stage, when the value n becomes 0, you need to process simply the reminders in the rows order. So conveniently, we are using this simple array concept so that the reminders are kept in the array which starts at location 0. For example, n is equal to 17. How do we convert 17 to divide by 2? 8 into 2, 16. Remainder is 1. 2. 4 into 2, 8. Remainder is 0. 2. 2 into 2, 4. Remainder is 0. Then 2. 1 into 2, 2. Remainder is 0. Then again, right, if we divide by 2, 0, right, remainder is 1. So this step, right, we can additionally have when we convert or when we program, so that this 0 is omitted. Only the reminders are considered 1, 0, 0, 0, 1. So what are the place values? This is 1. Multiply this 1 by 2, 2. 1 into 2, 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. So multiplying the individual binary bits with the place values, we have 1 into 16 plus 0 into 8 plus 0 into 4 plus 0 into 2 plus 1 into 1. So it says 16 plus 1 is equal to 17. Now just think of this is stored at location say x of 0, this is at location x of 1, this is at location x of 2, this is at location x of 3, this is at location x of 2. Now, this is for example initially the value of some j is equal to 0. Here the index j is pointing 1, here the index j points 2, here the index j points 3, finally the index j points 4. So starting from the index j 4, 3, 2, 1, 0, when we print these values 1, 0, 0, 0, 1. Am I right? This is a simple logic to find out the required conversion, decimal to integer conversion. Have any doubts in this logic? Subsequent right reminders are continually stored in the array indices, array locations. Array indices here start at 0, 0, 1, 2, 3, etc. That means j is equal to 0, 1, 2, 3, finally 4. When we print the value of j, when we print the array elements, right, using the indices which starts at right j, last value of j, in the reverse order, it seems we have the required conversion, right? 1, 0, 0, 1, 0, 0, 1. So how long we need to backtrack or traverse in the back direction until the index j reaches 0. Start at j is equal to 4. Then check if j is equal to 0. If not, j is decremented by 1. Then print the array value x of j. Then check the value of j, right? So this way you need to continue. When j reaches 0, we have printed the value. So that stage you need to terminate the process. This is a logic to convert further this algorithm step sequence of steps into the equivalent implementation. So next we need to just think of the scenario or this process with the help of an array, so that we need to use the for loop, because 17 by 2, 8, 8 by 2, 4, 4 by 2, 2, 1, right, 1 by 2, right, 0. So continually we can iterate the process using a for loop along with the array implementation. Then we can print the array elements in the reverse order. Hope you understand this logic. Have any doubts in this? Pooja, Monisha, Rahul Raj, Vignesh,
So no
Sudha
doubts,
Jeet.
sir.
Sir, clear, sir. No, that's
Okay,
No doubt, sir.
now
No doubt.
good. Now let us see its implementation. Can you please take this program, file, new, sorry, new, okay. Decimal to, the problem is convert the given integer into binary form and print it, print the result. This is the problem. File name, I think, CP50. Okay. Let us solve the problem right using the function and print the result using the user defined function or simply function. Let us include the header file hash include stdio.h function prototype. We make it later into main. Inside the main function, let us have one variable int n printf /n, enter the value of n, then write a scanf statement, scanf percentage d ampersand n. Let us have a function here, assuming that the function computes the equivalent binary form, and subsequently the result is being printed in the function itself, because here the reminders are going to be processed. So assuming that the reminders are printed in the function definition itself, we don't have any return type. So let us keep, right, the return type is void. Assuming the function name is say decimal or integer, decimal underscore to underscore binary, assuming one formal parameter is say n. This is the function definition that we need to complete. Here let me complete the main function having one statement return 0. Here, since the function would not like to return a value to the calling things because of its reminders printing, we have logically write the return type as void. Let it be like this. Simply calling decimal underscore to. So please understand the basic rules. The name given to n is here actual parameter. Here the name given to this n. This is the formal parameter. The actual parameter n is assigned to the formal parameter n here. So within this function definition, decimal to binary, we need to convert n into the equivalent binary. Convert n into equivalent binary. Please think with respect to its array implementation, as we done here, we need to declare one local array. We know that variables can be declared inside the function other than the formal parameters if we require. So here I declare one integer array, for example int x of 50 or int x of 10, maximum, right, 10 numbers in terms of zeros and ones. That means the 10 reminders, right, can be stored in the integer array x of 10. Now it's time for you. You need to write, tell me, how do we convert this scenario into C language implementation? N, right, n 17. 17 by 2, 8. 8, then reminder is 1. This 1 is being assigned into the 0th location in the array. More about arrays, right, we will explore later in the third unit. As of now, just to have basically how these array indices are accessed using this form. Array name, then this is the array bracket, square bracket. Here specify the index variable, so that value add or value of that index is referred by, or value of index j is referred by x of j. X of j means the jth location in the array x. Both are same. Now, can you tell me what is the next statement to be returned? Any idea with respect to this conversion? Array is declared, that part is over. This part, coming to this core part, I highlight here. Please tell me what is the equivalent conversion. We have seen several examples how to simulate this highlighted place into a C language implementation. This is simply dividing the value of n by 2. How long we are continuing until n becomes 0. Of course, normally, right, we will be stopping right up to the stage 1 0. Right, manually when we solve the problem, we can write right starting from this one. But in the program, until the value n becomes 0, we can iterate. Yes, tell me.
Sir, your voice is breaking, sir.
So see, this stage we need to convert the scenario into the equivalent for loop or while loop. How do we convert the scenario into the equivalent looping constructor? Any idea? Vignesh, Vishal Ram, Pooja, Vasudha, Jeet, Bhargav, Rahul Raj. How do we process this iterative one? What kind of looping is necessary here? Shall I use a for loop? For, suppose declare one variable j for j is equal to 0, then how long we need to continue the process? We need to continue the process until n becomes 0. For j is equal to 0, then n, shall we write this way, n greater than or equal to 0, j plus plus, here shall we write, first what we have to do, n should be divided by 2 and the remainder should be stored in a variable x of j. So how do we find that remainder? How do we find the remainder?
Modulus, sir.
Modulus, very good. So shall we write this in the assignment statement? I am expecting you to tell me the assignment statement. How to store this 1 into x of 0? What is this 0? 0 is the value of a variable j. So x of 0 stores the number 1 or integer 1, of course. How do we write the assignment statement here? First assignment statement. Please tell me, right, whatever is right or wrong. Let us discuss and correct it. Yes, can you please make it fast? How do we store this 1 into this 0th location in the array? That is, when j is 0.
Sir,
Yes,
x of 0 equal to n modulus 2.
very good. X of 0 is equal to n modulus 2. But actually here, every stage, we need to find the iteration. So little bit modification in this statement. Index 0 should not be used. The 0 is controlled through the control variable j. So we need to replace this 0 by the variable j. Okay. So x of x of j is equal to n mod 2. Okay, very good. Then what next to do?
Sir, n equal to n by 2, sir.
Very good. N is written as I left some spaces. N is equal to n by 2. So what happens? N is subdivided by 2. Yes. Then control checks before that the variable j is incremented by 1. I point highlighting here. J is incremented by 1. Then control checks if n is greater than or equal to 0. If it's so, x of j is obtained by performing the modulus operation as n mod 2. Then n is subdivided by 2. So whatever we have highlighted here, this process is simulated using the for loop along with these lines of code, LOC, lines of code. So hope when n becomes 0, n is greater than or equal to 0, then what happens? X of j is equal to n mod 2 and n is equal to n by 2. If you write like this, will we face any problem? Suppose n is equal to 2. Just take, right, the decimal 2. J starts at 2. 2 greater than or equal to 0, condition is true. X of j is equal to 2 mod 2. 2 mod 2, right, what happens? 0. 0 is assigned to the 0th location. Then n is subdivided by 2. N is equal to n by 2. Now n becomes 2 by 2, 1. N is 1. J plus plus j is pointing the index 1. Current n is 2 by 2, 1. 1 greater than or equal to 0. Condition is true. X of j is equal to 1 mod 2. 1 mod 2 is 1. So x of 1 is assigned the value 1. So 1, 0, this is actually to be printed. Then n is equal to n by 2. Current n is 1. 1 by 2 becomes 0. Then j plus plus 0 greater than or equal to 0. What happens? 0 greater than or equal to 0. Condition is true or false. Condition true or false.
False, sir.
0 greater than or equal to 0. 0 greater than or equal to 0. Condition is true. 0 greater than or equal to 0. 0 greater than or equal to 0. Condition is true. Equality. So again control enters into the for loop. J plus plus n is n by 2, 0 by 2, 0. Infinite times cyclically for loop gets executed. It will not come out of for loop. So how do we solve this problem? How do we solve this issue? When n becomes 0, we need to terminate the process. So when n is greater than 0, suppose last n is 1. 1 greater than 0 condition is true. 1 mod 2, 1, that is processed in the variable x of j. Then n becomes 0. 0 greater than 0 after the increment of j. 0 greater than 0 condition is false. Control comes out of for. That's all. 0 greater than 0 condition is false. Am I right? So control comes out of R. When control comes out of R, what is the value pointed by the variable j? J is pointing the index 1 bit position next to the last remainder. Hope you understand. J is pointing the index, right? 1 bit position next to the last remainder. So ultimately, there is no value of current j because j is incremented by 1. Then the value n is to be tested. So what I have to do, I traverse back starting with j as j minus 1. How long we need to traverse until the value of j reaches the least index? That means j greater than or equal to 0, j minus minus. Simply I print percentage d without leaving any space because we need to have the outcome like this: 1 0 1 0 1 0 0 0 1, like that, right? So print a percentage d. The element at jth location in the array x is accessed by x of j. The value x of j is printed over the range of j starting at j minus 1 or to 0th position. Let us check the code. What we need to make, right? We need to make this as a function prototype. So I simply make copy paste, copy, then edit, paste. Simply I put semicolon, no problem. Int n or simply you can use. Right? The data type is retrieved. Int. File, save. Do we need to declare any other variables? Int n. Input is performed. This is the calling statement. Finally return 0. Function definition jx. Okay. We have to check for compile time errors. Good, the program has been successfully compiled without any errors. Click OK. Press Control F9. Enter the value of n. Let us check n is 2. Good, the result is 1 0. Control F9. Enter the value of n. 85. Check the result that we have obtained earlier. That is 85. 1 0 1 0 1 0 last 1. 1 0 1 0 1 0 last 1. We are getting the correct result. Then check it for 17. 1 0 0 1. Control F9. 17. 1 0 0 1. I show the trace for the 17 so that you will understand further in a clear way how we printed a value using the for loop again. Suppose n is equal to 17. With respect to our logic, j starts at 0, j is equal to 0. When j is equal to 0, x of j, x of 0 is this line I am pointing, I am highlighting here, please understand. X of j is equal to n mod 2, 17 mod 2, 17 mod 2 is 1. That means x of 0 is 1, please understand. Then n is subdivided by 2, n is equal to n by 2. I write here, n is equal to n by 2, 17 by 2, this is 8. Next stage, j is incremented by 1, j plus plus, comma, j plus plus, j becomes 1. So find x of 1. Before that, the condition is tested. n greater than 0. N, right? For example, here I write 17 greater than 0. Now n is 8 greater than 0. Condition is true. So x of j is 1. X of 1 is equal to, what happens? N mod 2. Current n is 8. 8 mod 2. I write and erase, right? 8 mod 2 is 0. Then n is divided by 2. N is equal to n by 2. 8 by 2, 4. J is incremented by 1. J plus plus. J becomes 2. Entry condition in the while loop is n greater than 0. N is 4. 4 greater than 0. Condition is true. X of j, x of 2 is equal to current n mod 2. Current n is this one, 4. 4 mod 2. This is 0. Then n is subdivided by 2. N is 4 by 2. This is 2. J plus plus. J becomes 3. N is 2 greater than 0. Condition is true. X of 3 is equal to 2 modulus 2. This 2 modulus 2. 2 modulus 2. Remainder is 0. Then n is subdivided by 2. 2 by 2, 1. J plus plus. J becomes 4. Current n is 1 greater than 0. Condition is true. X of 4 is equal to 1 mod 2. Sorry, 1 mod 2 is 1. Then n becomes 1 by 2. 1 by 2 integer division, very important. This is not 0.5. 1 by 2 is 0. J plus plus. J becomes 5. Have a look into this current n. Current n is 0. This is the updated value of n. Current n is 0. 0 greater than 0. Condition false. So control comes out of first part. Then what we need to print? We need to print x of 4 first. Then print x of 3. Then print x of 2. X of 1. X of 0. I show here how to print. X of 4 is printed. That means 1 is printed first. Then x of 3 is printed. 0. This is x of 4, x of 3. Then x of 2, 0. Then x of 1, this 0. Then x of 0, this 1. So that we have the result 1 000 1 in the binary representation. Why we have to decrement the value of j by 1? After the last operation n is equal to n by 2, since we had incremented j by 1 because of this j plus plus, currently that's what I have said, j is pointing one index next to the last remainder. Last remainder is this 1. Its next bit position or index is actually x of 5. We are not processing x of 5, but since j is 5, we need to start at j minus 1. That's what here I have started a value of j as j minus 1. Please understand why we have started j from j minus 1, because after the last remainder j is incremented by 1. The value at that index j should not be processed. So we need to start from j minus 1 to index. Start at j as j minus 1. Check if j is greater than or equal to 0. If this is true, print a value of x of j. That means j is 4. Yes, j is here 5. J is decremented by 1. J is 4. 4 not equal to 0. Print a value x of g. Then j is decremented by 1. J becomes 3. 3 not equal to 0. Print x of j. Then j is j minus 1. J is 2 not equal to 0. Print x of j. Then j is decremented by 1. Where we kept write this decrement operation here after printing the value of x of j. J is 1. 1 not equal to 0. Print x of j. Then j becomes 0. 0 greater than or equal to 0. Yes, the condition is true. Print 0. What is our condition? Yeah, we have checked right not equal to 0, not equal to 0, but actually right greater than or equal to 0. This is actually right greater than or equal to. Please change it. Greater than or equal to, greater than or equal to. This is greater than or equal to. 0 greater than or equal to 0. Condition is true. So print x of j. X of 0 is greater. Then j is decremented by 1. Next value of j is 0 minus 1. J is minus 1. Then j greater than or equal to 0. Condition is false. Control comes out of this second part. That's all. No need to have any other statement. So that we have completed the printing of reminders in the reverse order, starting at index j minus 1 to reach the lossy index as 0, right? That is in the reverse order. So that whatever we have, the input value, suppose n is 111, 111 equivalent in binary form is 11041. Please check it. This is the logic to convert the given decimal representation into the equivalent binary representation. Have any doubts in this example? Have any doubts? Have any doubts? Please ask me. Okay, in case the problem is convert the given integers right within the range into the equivalent binary form and print the result. That stage we need to make a little bit modification. For example, I try to write this file, edit, select all, edit, copy, file, new, edit, paste. When the range is given, for example, construct the given in range of integers, given range of integers into binary form and print the result using function. Suppose the range is given. Enter the range. For example, we mean including first and last. FIRST, first comma last. We need to make a little bit of modification with respect to its range processing. Scanner percentage d, ampersand, ampersand, first comma ampersand last. Enter the range first comma last. There. First should be less than or equal to last. Okay, this condition should be satisfied. So first comma last, right? Okay, this space Okay, remove it. Okay. Then we need to process through the range. Suppose first is 10, last is 20. Convert all the numbers from 10 to 20, including 10 and 20, into the equivalent binary representation. So here what we have to do, we need to use a for loop to declare a variable for some j or some I is equal to, or take n, no problem, for n is equal to first n less than or equal to last n plus plus. That's all. Keep one space here. Decimal to binary n. So this decimal to binary n. This is the function call statement. The function call statement. This is processed over the range of n. For example, in between first and last. Here let us have the new line character. For example, here printf printf slash n percentage d, then slash d, comma. Let us print the value of n first without any modification. N is printed. Then slash t. Okay, no problem, right? It leaves some spaces. Then the value of equivalent binary form is printed. Then that new line character forces the output into the new line, the slash n. So this is okay. Let us check the code. File name. What is a file name? A
Sir,
CT51
variable
file.
should be declared and int data type.
Yes, first and last. Good. Need to be declared as integer data type. Int n, comma, first, comma, last. File has been saved. Compile time errors, 3 errors. What are the errors? Let us fix it. Unterminated string. Yeah, in C language here, if you write the slash enter character, such that this is taken as unterminated string. I continue in the same line. First less than or equal to last. Now this is okay. Save. F9. No errors. Control F9. First less than or equal to last. Suppose first is 1, last is 10. This is correct. 1 1 2 1 0 3 1 1 4 1 0 0 5. Okay. 6 7 8 9 10. Okay. Suppose if our range is n is 10, first is 10, last is a 50. In between, right, 10 and 50. Can scroll up here in case the output is not fit into the actual window. Ultimately, the scroll bar will be produced, and there is a need. This vertical scroll bar is produced. When there is a need here, horizontal scroll bar comes up automatically. 10, 10, 10, right? That is correct. 10, 1, 0, 1, 0, 11, 12, 13, 14, 15, 16, 18, 16, right? 1, 4, 0, 1, 2, 4, 8, 16. Yeah. Then up to the last number, 50, right? You need to check 1, 2, 4, 8, 16, 32. 32 plus 16, 48. Then 1, 2, right? 48 plus 2, 50. 48 plus 2, 50, 50. So this is a way, right, to make a little bit modification in case they ask to print the equivalent of binary, right, for the given range. So we need to control through the for loop here. for n is equal to first n less than or equal to last n plus plus. Simply call decimal to binary function or the given range of n. Inside the function, we have created the value of n and its equivalent binary form. Have any doubts in this logic? If you have any queries, you can ask. Any doubts?
Sir,
Yes.
sir, for the last program, can you show the output for entering the highest number when comparing to last number, sir?
Highest number comparing to.
I mean, the first will be highest when compared to lower.
Okay. There. 1 minute. Control F9. First one is 50. Second one is say 25. That's all. Nothing will happen because the entry condition into the for loop is n is equal to first. Taking if n is less than or equal to last. First less than or equal to last is tested. That is history. Okay. 50 less than or equal to 25. Condition is false. So control will not enter into this decimal to binary form. Nothing will get executed. In case if you yes,
So what did you change in that printf statement, sir? Why it showed wrong? Sir?
1 minute. Yeah, tell me.
So what did you change in that printf statement, sir? Why it showed syntax mistake error?
When
So before some error it showed, no, sir. In printf statement you changed something.
first right we have declared the variables. First and last are declared here. After the declaration of first and last. Yeah, okay. Yeah, you are asking this one. Print up. Yeah,
Yes,
I
sir.
got it. 1 minute only. Such that I logically write break the line into two lines. Enter the range first comma last such that first less than or equal to last. Because here after this you can see the horizontal scroll bar. You can find out. For example, here in case if you have a lengthy line, have you noticed horizontal scroll bar is available. Here you can find the vertical scroll bar. But logically, I return right this way first lesson or equal to last so that we have visibility. In this case, what happens? The compiler takes this double quotes. This is a string message, collection of characters. It considers starting from the slash and enter the range first comma last such that then this line right this is not continued. So in that case, if the continuation is given in the next line, compiler takes this is unterminated character string. Let me show it again. Yeah, you can see the message. Unterminated string or character constant in function main. F9, enter. The message right here you can see above the taskbar here. Unterminated string character constant in function main. So you cannot write a string in these two lines continually. This results in compile time error. So to avoid that, what you have to do, you need to write the entire string line in the same line. You need not worry about because the editor brings automatically the horizontal scroll bar, so that you will get the appearance in the singular. Got it?
Yes, sir.
F2, F9. Now no problem. So try to write the character string, character constant, or simply string constant, which are enclosed in double quotes in the same line itself. Then any other doubts? Okay, please go through the session. We will solve some other problems in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.